Okay, this one we're going to try to solve over here by taking the square roots. So again, you have to simplify everything and get rid of everything until you leave the r by itself. So I look at the left, I look at the right to see if individually, separately, if I can do something. But since I can't, then I'm ready to move things around. Okay, so once I'm able to move things around from one side to the other, then that's when I undo, okay? Because I'm going to move things around. So I got to do all my adding and subtracting first. Like here's a 4 that belongs with this one. This one here, the first one is an r squared term. The second one doesn't have a letter, so it's a constant term. And this 220 doesn't have a letter, it's also a constant term. I'm going to move this 4 over here. It was subtracting, now it's adding. See, I'm doing all my adding and subtracting first. So I got 4r squared equals 224. Alright, now I have this, right? There's no more adding, subtracting. I don't see any pluses or minuses. But I still have to move that 4 to the other side. Okay, it's right next to the r. So when something is right next, a number and a letter are right next to each other, they're multiplying. So now I'm going to jump over to multiplying and dividing. So here, the inverse of multiplying, or the opposite of multiplying, would be dividing by 4. Okay, why do I divide by the same sign? Because at the end, when I divide 4 divided by 4, I need to get 1 r squared. When you leave the letter by itself, the number in the front is an invisible 1. And then if I divide that, let's see, 50, I should get 56. Okay. Now I got to get rid of that square. So now I'm going to jump from multiplying, dividing to exponents. You see that? So here I got to get rid of that square. How do I do that? Well, I can square root both sides, right? Because the square root will get rid of that square. It's the inverse of the square. And don't forget that every time that you square root both sides, you have to consider the positive and the negative. Now you end up with a square root of 56. If you can simplify it, then you should simplify the square root. And the way you do that, again, you're going to think of prime numbers. What are your prime numbers? That's the 2, 3, 5, 7, 11, 13, 17, 19, 23, etc., 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 right? So I can look at this, and I think of my divisibility rules. I'm going to break this down into 2 factors, or 2 numbers that can multiply to give me 56. And it looks to me like, what is that, 7 and 8? Right? Because 7 times 8 is 56. Well, 7 happens to be one of the prime numbers. I can close that part of the branch. The 8 is not prime, so I can continue. I can get 2 other numbers that multiply to give me 8. 4 times 2, 2 is a prime number. I can continue with the 4. 2 times 2, and there you have 2 more prime numbers, and then all the branches are closed off. So in other words, the square root of 56 is the same thing as saying the square root of 2 times 2 times 2 times 7. And what you really need, since it's a square root, you need pairs. So here, that's 1, and the other ones are really by themselves, right? This one's by himself, this one's by itself. So I can rewrite this as a square root of 2 squared because of this pair right there. Right? 2 gives me 2 squared. And I still have one more. This one here, I got these 2 together. Right? But then I have this one by itself, and I have this one by itself. So then the green one here, I'm going to say it's square root of 2, and the purple 7 is the square root of 7. So all that did is it helped me because with these 2 pairs right there, I can cancel that square and the square root. leaving me the 2 outside. These two stay inside, so 2 times 7 is 14. And that's pretty much all you can do. So this is r equals plus or minus 2 square root of 14. And I have simplified my square root of 56. Square root of 56 is the same thing as saying 2 square root of 14.